Now, in this video, we are going to take up one more problem on the stress and strain, the problem number 9. A 25 mm diameter rod is subjected to a tensile load of 50 kilonewton. The extension of the rod was found to be 250 divisions in the extensometer of 200 mm gauge length. If each division of the extensometer is equal to 0.001 mm, find the modulus of elasticity. So here the data given is the diameter of the bar or the rod, which is 25 mm, subjected to a tensile load. So P is equal to 50 kilonewton, which means 50 into 10 to the power of 3 Newton. So it is 5 into 10 to the power of 4 Newton. The extension of the rod was found to be 250 divisions. So that is delta, which is 250 divisions. So the least count on the extensometer is 0.001. So that will be equal to 0.25 mm. And the gauge length, that is L, will be equal to 200 mm length. Find the modulus of elasticity, which I need to find out. What is the stress? Stress is nothing but the load by area of cross section. We know the load as P, and we know, since the diameter is known, the area of cross section, which I've been able to find out, which is pi by 4 into 25 square. So we can do that it has a strain, which is epsilon, which is delta L by L. So we know both the delta L by L, and that means we know the stress and strain. So we can easily find out the Young's modulus. So for that, the modulus of elasticity, E will be equal to sigma by epsilon. What is that? Which is P by A. Substitute the value of stress as P by A and the value of epsilon as delta L by L. So that means you're going to get it as P into L by delta L into A. Since I want the Young's modulus, so P is 5 into 10 to the power of 4 into, substitute the values. L is 200 divided by delta L is 0.25 into area of cross section is pi by 4 into 25 square. So on simplification, the modulus of elasticity E is 814.87.3 Newton per mm square. So 814.87.3 Newton per mm square. Now we'll go for one more problem. The problem number 10, a hollow steel tube is to be used to carry an axial compressive load of 150 kilonewton. The yield stress for steel is 250 Newton per mm square and a factor of safety of 2. The following 3 classes of tubes of external diameter 100 mm are available. So what are the different classes? The class and the thickness. The class light has got 3.5 mm, the medium is 4.0 mm, and heavy is 5.0 mm. Suggest the suitable section, what we need to find out. So what is the permissible stress? Permissible stress is yield stress by factor of safety, so 250 by 2, which will be equal to 125 Newton per mm square. Also, sigma is nothing but P by A. So P sigma is known 125 divided by 150 into 10 to the power of 3 divided by A, which is area of the cross section of the tube, which will be, on simplification, you will going to get it as 1200 mm square. For a hollow section of outer diameter D, capital D, and the inner diameter D, so we have area of cross section A will be equal to pi by 4 into capital D square minus small d square. So here we know the area of cross section of the tube is 1200 mm square, which we have found out from the previous this value here, and then divided by pi by 4 into 100 square, outer diameter is 100, and 100 square minus d square. So on simplification, the inner diameter d will be equal to 92.044 mm. So the thickness of the tube, which I need to find out, because the section what we need to find out is in the form of a thickness. So T will be equal to capital D minus small d by 2. So capital D is 100 minus small d is 92.044 divided by 2 will be, the value is 3.978 mm. So that will going to fall in the range of the suggested section in the medium class. In the later class, it is up to 3, and in the medium class, you will going to get this. So this is how you will be able to find the solution. Thank you.